Okay, this is page 2 of the network notes, and I'm just continuing with the intro. I said I'd mention a bit more about ports. So ports are network endpoints on a host. A host is just a computer or server in networking terminology, and it's like a phone extension. So the phone number gives you like the company you're calling, but then you want to reach a particular person, or in our case, a particular application, and the port number gets you that. So ports are a 16-bit number, 2 bytes. So they got a range of 0 to 65,535. Applications bind ports. So when you have a server that wants to listen on a particular port number, it will request the OS to direct all those requests coming to that port to that application. So it has bound that port, and there's a system called bind that does that. There's a couple of rules about port numbers. So ports with 0 to 1023 are what are called well-known, and really what that means is they are reserved. You can't use those. Why they called it well-known, there's probably a historical reason for that, but yeah, they're reserved. So examples are the Hypertext Transfer Protocol uses port 80, HTTPS, so HTTP over SSL, or that might just stand for secure. Is 443. Secure Shell is port 22. The Simple Mail Transfer Protocol is port 25. IMAP, which you use to read your mail off a server, is port 143. Okay. Ports 1024 to 49151 are registered, and there's a registry online. I think ICANN maintains it, the Internet Authority. Yeah, and so there are a number of applications out there that have registered to work with ports in that range. If you're just writing code for your own use, then it's better to stick with the higher port numbers. So you can reuse one of those port numbers in that range that are registered, but it's probably not a great idea, especially if it's a commonly used application. But port number 49152 to 65535 are what they call dynamic, and they also call them private. And the RFCs that describe internet ports. Whoops, just dropped my pen. Okay. So before we get into coding, let's just look at the telephone analogy. Can't even remember where I first saw this now, but it compares socket programming to telephone terminology. So we're going to have our server and the calls it makes here, and the client and the calls that it makes here. And I'm going to list what we're doing on the left here. So we're going to install a phone. The server's going to do that by calling the socket system call. So that's the first thing you need to do to work with socket programming is you have to create a socket and you get back a file descriptor for it. Then the server needs to get a phone number. So the client just needs to know where the server is, but it doesn't need to have a registered number itself. So get a phone number, and that is going to be the bind call that I just mentioned. And then the next step is, now that the server's got a phone number, it needs to wait for a call. And it can tell the operating system that is ready to accept incoming calls with the listen system call. Next, we need the client to request the connection. So they're going to, in our analogy, dial the phone number of the server, and the system call to do that is connect. So first you have to use the get address info to look up the host IP address, put it into that address info struct, and then you call connect with that. And then the host, or the server, needs to answer the phone, and they do that with the accept system call. And servers can have multiple open connections at the same time. So when you call accept, you get back a new file descriptor for that connection to that client, and you can work with it, meanwhile accepting new calls, especially if you do things multi-threaded. And then lastly, they want to talk. And so for streaming sockets, or the TCP sockets, you would typically use send and receive system calls, and they're like write and read. They've got one more parameter, which is some flags. I'll get to those calls soon. So they can just send and receive data. I guess that should be a slash. But they'll have to have kind of their own protocol about, who talks when and what the data that they're sending and receiving means. That's it for page 2.